Welcome back. It's time we actually designed this database for Grandma's Jams, Jellies, and Shine business. Should be great fun. We're going to normalize the database. Ba-dum-bump. If you recall from our earlier discussion, way back in the early 70s, a guy named out of IBM named Cod gave us relational theory. What he really gave us was normalization. And the idea is that if you properly set up a number of sets of data, you could write a structured query language that would operate properly on top of it. He gave us those rules by which to do that setup. The process is now known as normalization. And we're going to go through the steps to bring a data set from zero normal form through Boyce-Codd third normal form. Just as an FYI, there are additional higher normal forms. Nobody in the real database design world uses them. They're academic in nature, and the short answer is SQL will work properly on a third normal form database, so let's go there. Final thing to remember is that normalization is not difficult. It's just one of those things you got to take your time with when you first start out in this business, because mistakes are difficult to undo later down the road. So let's keep that in mind. All right, given that caveat, let's jump into zero normal form. Zero normal form is what we classically see in spreadsheets. Spreadsheets are sort of the bane of mankind as far as I'm concerned. Every accountant lives and dies by these things and thinks they're a database. They are not. The biggest issue with respect to a spreadsheet, it has no capacity to handle repeating fields. Let's take a look at an example and you'll immediately see what I'm talking about. All right. Given its popularity, just for fun, let's try to design a solution for Grandma using Excel. No problem with the customer information, works just fine. But look what we have to do to handle the multiple customer address situation. Oh, no way. Separate sets of columns for home address, work address, and then a bunch of addresses simply labeled others. How embarrassing. And how many other address sets do we actually need? Accountants, this is the database police. Take your hands off the spreadsheet and come out with your head down. Shame on you. In database normalization terminology, there's a name for that type of spreadsheet layout. Zero normal form, or simply 0NF. Here's another representation of our example database information. But now instead of a spreadsheet, we have modeled it using standard normalization format. In this case, 0NF, everything living in one big, fat, wholly unusable table. Check it out. Here we have our customer information again, customer addresses, orders, shipments. It's all here in one big blob of stuff. Oh yes, the bane of database mankind is 0NF. Hey, not to worry, we're just starting here and we'll work our way up the proverbial normalization ladder. All right, let's get out of the 0NF mess and into first normal form. How do we do it? Real easy. We remove all the repeating fields. To do that, we take each set of repeaters and we create a new table out of them. The primary key of that table is going to be a compound primary key made up of the primary key of the parent or non-repeater and then unique identifier for the repeaters. Real easy stuff. An example will make it painfully clear. Let's jump right in. In our previous lectures, we all agreed that customer address was repeating with respect to the customer entity. Okay, let's start by creating our customer table. We all agree that our customer entity has 4 attributes: first and last name, email, and phone. But what about a unique identifier for our table? Right, we need a primary key, right? No problem. Standard practice is to simply add an artificial primary key, customer ID. A simple ascending sequential integer will work just fine. as is also standard practice in normalization documentation, will underline the primary key of our customer table. Okay, you may be asking why we didn't use email as the primary key. It is a primary key candidate because it's probably unique. Standard practice is to use these artificial ascending sequential integers because that information is real small. Primary keys are realized within an RDBMS via B-tree indices. The more of segments we can get on a page of memory, the better off we're going to be with respect to performance. And as such, generations have taught us that we're going to use these artificial primary keys made up of simple ascending integers over long potential character fields like emails. Okay, cool. Understood. Now let's remove that repeating customer address entity by creating a new table called customer addresses. Let's add in all those address attributes and then copy the non-repeating parent PK. We now need to add a PK segment for our repeaters. We'll call that bad boy simply address ID, and again it will be a simple ascending sequential integer. Hey, if that strategy ain't broke, I'm not the one who's going to fix it. The combination of customer and address IDs will make up our new compound PK for the customer addresses table. All right, we continue removing repeaters until we have this set of 1NF tables. Notice how shipment has 4 primary key segments because it is a one-to-many with line items, a one-to-many with orders, which in turn is a one-to-many with customers. Don't worry, gang, we'll clean that baby up before too long and it'll look much better by the time we're finished. All right, 1NF is a good jump on our normalization process, but you ask, how do we get to second normal form? Not a problem. You get to second normal form by removing partial dependencies. That is a set of attributes within the table which are dependent on part, but not all of the segments of a compound primary key. Sounds like a lot of mishmouth, but once you see an example, it'll all make sense. So let's jump right back to our data. Let's take a quick look at our first normal form shipments table. It's got all these address attributes in there. Those fields simply represent the address used in a specific shipment, i.e. a row out of the customer addresses table. Clearly, all these values are only dependent upon one thing, and that's our customer ID. Yup, you got it. These address attributes in the shipment table are partially dependent on the customer ID segment of this compound primary key. So let's get them out of there. All right, check it out. We do that. We end up with this table I'm labeling customer addresses prime. Same exact table as customer addresses, so we go ahead and delete that redundant table. What's the rule for eliminating a table? That table you must remove any table which is a subset of another table and shares the exact same primary key. All right, our criterion are met here, so we got to delete that table. It's the clean thing to do. You don't want to store things in 2 different locations when in fact this information is the same. All right, who packed a shipment is not dependent in any way on the line items making up that shipment. Fine, let's create a master shipments table and a child shipments table which contains the line item information. We'll now associate the packing guy with the shipment rather than the line items. I like that. That'll work. All right, gang, time to sprint to the finish line here with our normalization process. That is, take our second normal form tables and bring them up to third normal form. Means by which we do that is we look and remove any transitive dependencies. You all remember your rule for transitivity. A is to B, B is to C, therefore A is to C. All right, what do? We create the B entity as a new table and leave the primary key of that new table in the table we took those attributes out of as a foreign key. Again, a simple example and we'll be good. It'll all make sense. Let's jump in. All right. Right off the bat, we see this product entity. Line item defines product, which transitively defines price, width, and length of that product. All right, that's transitive dependency. We need to remove the product. Let's get those out of there and into a new table called products. We ensure our relationship remains by leaving product ID in the line items table as a foreign key. The standard notation for a foreign key is to italicize it. Same thing with these shipping boxes and the person responsible for making that shipment. Two new tables called employees and shipping boxes, and we leave the foreign keys to enforce referential integrity. By referential integrity, I mean nothing more than I'm never going to create a shipment that references a non-existent shipping box or a non-existent employee. That is, we're not going to allow users to put junk into our database. Before we leave this topic, I want to check out the manager ID in the employees table. Looks like a foreign key, right? Well, yes, and that foreign key is actually pointing back to the employees table, i.e. the person who manages the current individual. This type of relationship is known as a self-join. When we start writing queries, these will be particularly fun and so exciting. And finally, before we quit, I want to show you one more optional design point. Everyone who's ever coded a drop-down box, or more interestingly, cascading drop-down boxes, knows that the value of those drop-downs often comes out of the database to ensure data quality and consistency. As such, let's just go ahead and add the countries and state provinces tables so we can play that game as we go forward with our designs. Note, now country and state provinces will make a very nice pair of cascading drop-downs. Okay, that puts a bow on our normalization process other than to briefly discuss Boyce Codd third normal form. Boyce Codd were a couple of scientists also working at IBM, I believe, back in the mid-70s, and they enhanced Codd's third normal form by suggesting that there might exist partial dependencies within the segments of a compound primary key, and that those should be flattened in a fashion similar to 1F to 2NF changes. I very rarely see BCNF situations, but if you do, please flatten them out as I just suggested. A more common situation is to remove some of these segments from these very large primary keys and use joins when we get to SQL to put them back together. And again, that's a performance issue that we'll talk about as we move forward. But remember, these primary keys are realized via B-tree indices in the database, and the smaller we can make the primary key segments, the faster our database is going to run. So I'm going to be teaching you not only what the theory says, but what actually happens in reality when we go to build these databases. All right, a little quick summary before we wrap this thing up. We went from 0NF or spreadsheet mode through first normal form by removing the repeating fields. How did we do that? We made a new table with the repeating attributes with a compound primary key made up of the primary key of the parent non-repeaters and the unique identifier for the repeaters. We then brought our first normal form to second normal form by removing any partial dependencies, a partial dependency being defined as attributes within a table which are wholly dependent on part but not all of the segments of the primary key. Real easily done. We just bring them out and make them a new table. Finally, we went from second normal form to third normal form by removing any transitive dependencies. You all know, given your mathematics and computer background, what transitivity is. It's A to B, B to C, therefore A to C. In our case, we're going to remove the B entity and make it a separate table and leave the primary key of the B entity or B table in the original table as a foreign key, thus establishing a relationship between those two tables. Easy enough. Finally, if you're so inclined, and you probably should be, you want to bring your design up to Boyce Codd third normal form. You remove any partial dependencies within the multiple segments of a primary compound primary key. Easily enough done. All right, that was pretty fun. What do I suggest? Please print out the resource materials on this lecture and give it a quick study. Normalization is one of those that once you see it and you have a set theory background, it's really pretty straightforward. Similarly, as you do more normalization processes or go through the process more times, you're going to start jumping right to BC3 and F because you can sort of see it without thinking your way through 0, 1, 2, and 3 forms. All right, I hope you had as much fun as I did. As I suggested, please do review the resource materials for this lecture because they'll help you make sense for all this going forward. I had fun. You go out there, have some fun too. We'll see you in the next lecture when we start talking about entity relationship diagrams. In the interim, hey, learn something every day.